Hello again. We're going to do chapter 10.5, applications of percents. And there's 4 things we need to know. The first thing is percent, which is a little bit of old news to us. We have the symbol percent, and it means 2 things. Times 1 over 100 or times 100th. As long as we keep this in our mind, we'll be pretty safe. There's a couple of things about percent which we'll explore later on, where sometimes when we are given the word, we like to use this meaning, and if we're just given a number like 50%, then we like to directly translate it into the decimal version. Or you could view it as 50 hundredths. It doesn't make a difference. So we'll alternate between the two during this chapter. The next thing that we need to know is. Is translates to us as equal, so we'll always use the equal sign whenever we see is. Of translates to multiplication, and what is our unknown, so we use x usually, but any variable will do. So if we keep these in mind, we're going to go ahead and tackle our first problem, in which we're going to directly translate what each thing means. So we have 35%. Now, you can view that as 0.35 or 35 over 100. It doesn't make a difference which one you use. Most students like to use the decimal, so for this one, I'll go ahead and use 0.35 to represent 35%. Of translates to multiplication. 780 is means equal to, and what number? We don't know what number, so we'll use x. After we've translated, our next goal is to solve for x. X is already by itself, so all we need to do is the multiplication of 780 times 0.35. And we'll just do it. So we got 5 times 0, 5 times 8, carry the 4. 5 times 7 is 35, plus the 4 is 39. Placeholder, don't forget it. 3 times 0, 3 times 8 is 24, carry the 2. 3 times 7 is 21, plus the 2 is 23. And we'll add them up. And then we have to count how many decimal places were involved. We had 2, so we move over 2. So our answer is 273 is the number we're looking for. So be careful. We always have to answer their question. They wanted a number, so we'll just give them a number. Sometimes they'll ask for percent, so we have to be careful and make sure we answer the question with a percent. The next one we have, it's a little bit different, but still the same flavor. We have 135% of what number is 54. So we'll just translate it the same deal before. We have 135%, which is a little odd for some students. If we were to translate this into a decimal, it's 1.35 because you have to move over 1, 2 to the left. Of means multiplication. What number? Well, we don't know, so x. Is means equal to 54. Now, we solve for x. X isn't already solved for it by itself, so we have a little bit of work to do, unlike our previous one. But same nice problem. We have 1.35 times x. So we want to undo that by dividing both sides by 1.35. And what we do to one side, we have to do to the other. Now we're left with x equals. We can't divide by decimals, so we'll move it over 2. What we do to the bottom, we got to do to the top. So we have 5,400 over 135. And now we can go ahead and do the long division. If the long division works out not so pretty, I might encourage to write the answer as a fraction, but I'm not too sure just yet. If you're ever worrying about what form your answer should be in, look to your directions. If they tell you write answer as a fraction or write it as a decimal, do what they say. If they don't, usually I like to leave it as a fraction because it looks nicer, but let's just be safe and check if we can simplify it. So 135 times what will get us close to 540. Probably 5 will be too much, so we'll give 4 a shot. So 4 times 5 is 20, carry the 2. 4 times 3 is 12, plus the 2 is 14, carry the 1. 4 times 1 is 4, plus the 1 is 5, and that actually worked out beautiful. And we have x must equal 40. So let's be careful. Let's see. They wanted what number? So we'll just tell them the number, which is 40. Alright, let's see one where they ask us what percent. So what percent of 150 is 6? What? We don't know. Percent. So go back to what we translated. It either means times 100 or times 100, be it fraction or decimal notation that you prefer. When we had the numbers, we could directly translate them into a decimal or a fraction if we chose to. Here we don't have a number with it, so we're going to have to write times, and I'm going to recommend to use the fraction here. I use decimals when they actually give a number, but if they don't, a fraction is much better. Of means multiplication. 150 is equal to 6. Alright, so now let's view this. This 150 is really over 1. We can actually reduce this a little bit before we start solving for x. 10 can go into both of these numbers. We have 15 over 10 times x equals 6. And you might be going, well, you could reduce that further, and you're right. 5 can go into both of them. So we have 3 halves x equals 6. A lot cleaner of a problem. Now it's 3 halves times x, so to undo it, we divide by 3 halves. And what we do to one side, we have to do to the other. So now we have x is by itself, because the 3 halves cancel out. And we have 6 divided by 3 halves. Whenever we divide by a fraction, instead we keep, change, flip. And sure enough, 3 can go into 6 twice, and we have 2 times 2 is 4. Now be careful. Let's make sure we answer the question. They asked us what percent. So our answer needs to include the unit that this is 4% that we found. So those are the 3 types of problems you'll have for solving these percent applications. There's another different type that you will have in which you're going to have percent of increase and decrease, which is the change or the increase or decrease, whatever it may be, over the original. So we're going to go ahead and tackle this problem with this in mind. In 2006, there was 50,000 pharmacy aides in the United States. This number is expected to drop to 45,000 by 2016. What is the percent of decrease? So our first step is we need to find the change. In 2006, there's 50, and then by 2016, there's predicted to be 45. So we're going to find the change, in which case is the decrease here, between 50 and 45. So we'll subtract the 2, and 5 here is how much they'll decrease over the years. Now we want to find the percent of the decrease. So we're going to take 5 and divide it over the original. Well, there's originally 50 in 2006, so we're going to take 5 over 50. Now we need to turn this into a percent, so however you choose to do it, go for it. The easiest way here is, since you look at the denominator and it's already 50, you can times both top and bottom by 2, in which 50 times 2 gets us 100, which is what percent means, and 5 times 2 is 10, so 10% must be the percent of decrease. You can also take 50 and divide it into 5. You can reduce the fraction by whatever means is necessary. Let's go ahead and tackle the next one. This one's going to be a percent of increase. Consumers are paying record amounts of fees for overdrawing their bank accounts. In 2007, banks, thrifts, and credit unions collected $75.5 billion in overdraft fees, which is $15.1 billion more than 2001. What is the percent of increase? Okay, well, we actually don't know what we started at. We don't know the original start for 2001, but we actually know the increase because it's $15.1 billion more. So we already know increase. Now what we need to figure out is the original. Now we know by 2007 it's 75.5. If we were to take away what we increase by, we will end up with our original, what we started with. So let's see, we'll line up the decimal points, subtract. So we have $60.4 billion was how much the banks and credit unions collected in 2001. So now what we need to do is take 15.1 and divide it by 60.4. It's up to you how you want to tackle this. I'm going to go ahead and make sure I move my decimal point over because I don't want to divide by a decimal. So I have 151 over 604. And you can do the long division, or maybe you see that you can reduce the fraction by something. It's not really jumping out at me what this can reduce by. I do in fact know the answer, so I'm tempted to reduce it, but I don't think normally I would see it. So I'm going to go ahead and do the long division. And we'll line up some decimal points here. And we go 600 times what will get us close to 1,510. And I'm going to guess 2 is probably the best we got. So 2 times 4 is 8. 2 times nothing is 0. 2 times 6 is 12. So we'll subtract. We got to borrow. We got 2, nothing, and 3. Let's bring down the 0. Alright, well, 6 times 5 is 30, so let's see. Let's give 5 a shot. 6 times 4 is... I'm sorry, I said that wrong. 5 times 4 is 20. Carry the 2. 5 times nothing is 0, plus the 2. And then 5 times 6 is 30, and that worked out lovely. So we got 0.25, or 25% of increase. And that is all.